Okay, we're going to look at a couple more examples, and this first example is going to be extremely important. And this, what we're going to do is we're going to take a high order ODE, we're going to convert it to a system of first order differential equations. And this technique is extremely important because oftentimes we can't actually solve differential equations. We need to use a computer to approximate them. And there's a lot of really good algorithms out there for approximating systems of DEs, but the ones for higher order equations are not necessarily all that great. So it's a very common practice to take higher order ODEs and write them as systems so that you can then put them on the computer and build an approximation from there. Okay, so first example, suppose we have x double prime plus 3x prime plus 2x is 0. You should be able to go through and show that the solution is of the form a constant times e to the minus 2t plus a constant times e to the minus t. And note that the dominant term is e to the minus t, and it's going to decay like e to the minus t in the long run. Now, I would like to write this as a system. So like another way to attack this. And here's the thing to notice, is if I take the derivative of x prime, I will get x double prime. So the derivative of x prime is x double prime. So if I introduce a new variable, we'll let y equal x prime, then the derivative of y is the derivative of x prime, which is x double prime. And note, this is a first order equation, and I can take this and substitute into here and then solve for y prime, noting that this is y here, and I'll get a second equation with only one derivative in it. So let's go through that. So I have x double prime plus 3x prime plus 2x is 0. I'm going to let y equal x prime. So now that's my y. Y prime will be x prime, x double prime. So there's y prime. So it becomes y prime. 3x prime becomes 3y plus 2x is 0. And if I solve this for y prime, I get minus, subtract 2x from both sides, subtract 3y from both sides, and now I have a system of equations. The derivative of x and y, well, the derivative of x is y, derivative of y is minus 2x minus 3y, and I can write that as a matrix times xy. So derivative of x is equal to y, that's 0x plus 1y. Derivative of y is minus 2x minus 3y. So this equation here is the same as working with the derivative of xy is equal to matrix times xy, and that matrix is 0, 1, minus 2, minus 3. So what just happened is I started off with x double prime plus 3x prime plus 2x is 0. I let y equal x prime, which meant that y prime is x double prime. And I got the derivative of xy is equal to 0, 1, minus 2, minus 3 times xy. And now you can solve this as a system of equations. I'm not going to go through and do that because you should be able to do this at this point. At this point, you should be able to go through and do the calculations with this matrix and find that lambda 1 is minus 1, and its eigenvector is 1, minus 1. Lambda 2 is minus 2, and its eigenvector is minus 1, 2. So I've got two independent eigenvectors. So my solution is equal to c1 e to the minus 2, 1, 1, plus c2 e to the minus 2t times minus 1, 2. And now you should be able to look at this and say it decays because the real values of both eigenvalues are negative, and this is the dominant term here, so it's going to decay like this. Notice for this second entry, I get 1 times this plus a 2 times this, but it's times a constant. This is basically going to be the same thing as the derivative. Okay, so let's see. Let's look at another example. And I'm just going to use this example to set up the system, and I'm not going to solve the system, just so you have an opportunity to see just another example of how you work with these things. So suppose I have this system, or this second order equation. I want to write it as a system. I'm going to define y to be x prime, so that becomes a 5y. Y prime is my x double prime. So this becomes a y prime. X prime becomes y, so that's plus 5y plus 8x is 0. I'm going to solve for that. So solve for y prime. It's going to be minus 8x minus 5y. And from this equation, I get that x prime is y. So the derivative of my state, which is now xy, is going to be a matrix times xy. First equation is here. So that's going to be just equal to y, so 0x plus 1y. Second equation comes from here. So this is going to be minus 8x. So we have a minus 8 minus 5y. So that coefficient is minus 5. So the derivative of xy is equal to the matrix 0, 1, minus 8, minus 5 times xy. And again, it's really important for you to be able to do that and then solve that equations. We'll look at one more example here. This is going to write this as a system. So the derivative of the vector x is going to be minus 8, 30, minus 3, 10, x. Okay, I'm just going to state the eigenvalues and eigenvectors. And let's go through and do it. This is going to be fun. So the first thing is to find the eigenvalues. So I'm going to take the diagonal entries and subtract lambda. So I get minus 8 minus lambda. Leave the 30 alone, leave the minus 3 alone, then take a 10 minus lambda. Take that determinant, set it equal to 0. This is just multiply the diagonal entries together, subtract the off-diagonal entries multiplied. All right, I'm not going to go through and do all this. If I multiply all that out and expand it and bring it all together, you get lambda squared minus 2 lambda plus 10 is 0. I'm not sure how to factor that just offhand, so I'm just going to use this quadratic equation. I can mess around. Minus a minus 2 is 2, plus or minus. We have minus 2 squared minus 4 times, there's a 1 here, 4 times 1 times 10, all over 2 times 1. So I'm going to clean that up. 2 plus or minus 2 squared is 4, minus 4 times 10 is 40 over 2. So this becomes 2 plus or minus square root of minus 36 over 2, which is 2 plus or minus 6i over 2. So I get 1 plus or minus 3i. Now, a week or so ago, you would have been very upset over that, but now you know it's not a big deal. You just treat it like regular numbers and just be careful and work through it slowly. So I'm going to say lambda 1 is 1 plus 3i. Lambda 2 is 1 minus 3i. And right now, you should immediately be able to tell me that it's going to oscillate because I have non-zero imaginary parts. The amplitude is going to grow like e to the t, so it grows exponentially. It's going to oscillate like sine of 3t or cosine of 3t. So the period is going to be 2 pi over 3. You should be able to work this all out on your own and explain and show me why that is. For the eigenvectors. I'm going to get the lambda 1 and then just tell you what I get for lambda 2 because it's a lot of work. And yeah, you don't want to see it. So just like before, I am going to, let's see, take my original matrix and I'm going to subtract the eigenvalue from the diagonal entries. So the first diagonal entry is minus 8 minus the quantity 1 plus 3i. I'll leave the 30 alone, leave the minus 3 alone. Then I'll get 10 minus the quantity 1 plus 3i. I'm looking for a vector that maps that to 0. All right, so where are we? We are working with this differential equation. We have lambda 1 is 1 plus 3i, and lambda 2 is 1 minus 3i. And, by the way, notice, just like before, the imaginary parts are the same, but just off by a negative sign. It's going to be very important. We're going to see the exact same thing with the eigenvectors. And so now I have, for my first entry here, I have minus 8 minus the quantity 1 plus 3i. So it becomes minus 9 minus 3i. And the 30 minus 3 get left alone. Then 10 minus 1 is 9. Then minus 3i. And I'm looking for that. So I've got two equations. Minus 9 minus 3i x plus 30y is 0. Then minus 3x plus 9 minus 3i y is 0. If I solve this for y, I'm going to get 30y. If I add that to both sides, I get 9 plus 3i x, or y is 1/30 9 plus 3i x. So that's going to be, what, 9/30 plus 3/30 I times x. So 9 divided by 30, that is what, 3/10. Then 3 over 30 is 1/10 I. So my eigenvector is going to be xy. And then leave the x alone. I'm going to get a 3/10 plus 1/10 I x. You can factor out the x to get that. All right, and now you should be concerned. That seems kind of arbitrary. Why did I not look at this second equation? And I should get the exact same result. If I don't, that's a problem. So let me add, let's do this. Let's solve, yeah. So I solved for y here. Let me do the same. Let me add 3x to both sides. And I'm going to divide by minus 9 minus 3i x. Oh, yuck. So I'm going to multiply top and bottom by the 9 plus 3i. We've seen all this before. It's exactly what we've seen before. So what do I get? I'm going to get 3 times 9 plus 3i. This becomes 9 times 9 is 81. I have minus 27i plus 27i is 0. I'm going to have minus 3 times 3 is minus 9 times I squared, so it's going to be plus 9. And the x comes down. So this becomes 3/90 over 9 plus 3i x. 3/90 is 1/30. And notice that is exactly the same thing I had here. And it's going to simplify exactly the same way to this same expression. So I have lambda 1 is 1 plus 3i, and the eigenvector is going to be 1 and 3/10 plus 1/10 I times any number x. All right, so where are we? Again, we had derivative of x is minus 8, 30, minus 3, 10, x. We have eigenvalue lambda 1 is 1 plus 3i. Its eigenvector is anything times 1, then 3/10 plus 1/10 I. Lambda 2 is 1 minus 3i. I'm not going to go through and find v2. But if you were to do that, and you should do this and be able to show me this, you can get exactly the same thing, but the imaginary part is going to be off by a negative sign, and that should happen every time because we started off with real number matrix. If that's not the case, you did something terribly wrong. But what does this mean? This means that my x of t is going to be c1 e to the 1 plus 3it times v1, which is 1 3/10 plus 1/10 I, plus c2, then e to the lambda 2t, so 1 minus 3it, 1 3/10 minus 1/10 I. All right, in your book, your author goes through a huge amount of algebra and just awful manipulations to show that you can write this in an equivalent way. This is perfectly fine to leave it like this. What really matters is you be able to interpret this thing and what that means. And what this means is e to the t plus or minus 3it, which is e to the t times e to the plus or minus 3it. And you should be able to look at this and say, it's going to grow like e to the t, and it's going to oscillate like cosine of 3t and sine of 3t. All right, and again, what that means then is that it's going to have a period. So 3 times the period should be 2 pi. So the period is going to be 2 pi over 3, which is exactly what we said before.